Okay, so here we have a spring, so not a string, so it won't go slack at any point. We're told the natural length is A and the modulus, so let's make a note, lambda equals K M G, and we know the lateral length is A. Okay, so it's held at rest and it comes to rest at B. B is up here. So it's held at rest here and released and comes to rest B. So we're going to do an energy. So energy at A is all it's got. We take H as 0 here. We've got, I'll take that as my base if you like. H is 0. All it's got is elastic potential energy. So it's K mg x, which is 2a in this case, 2a squared over 2a, which equals 2 k m g a, because that will cancel with that. Okay, the energy at B, so B, it's got elastic potential energy still, albeit because it's a spring it's going to be thrust, which is what makes this quite important. So we've got lambda times half A. It's in fact compressed because the natural length is A, so it's compressed by half A, squared over 2A, and it's got gravitational potential energy, and it's 2.5 A is the height times mg. Okay, there's no loss of energy in this case, no work done against friction, so we know energy A equals energy B. So that tells us that K A squared, so 4K A squared mg not 4, sorry, 2, apologies, because I've got rid of the square, haven't I? 2k a squared mg equals, let's say a squared there, 2k a squared mg equals, this is a quarter a squared, so the a's will cancel, so we get k mg, a squared over a is a, quarter divided by 2 is an eighth, plus 2.5, let me write it as 5 mg over 2. Okay, so what am I going to get? So kmg over 8 a squared mg, amg, okay, so right, now made another little slip. This squared shouldn't be here, should it? Because I've got an a squared over a. Shouldn't be there. Okay, 2k am. So now we've got 2k mg and we've got km. So get rid of the m's, the g's, and the a's, in fact. So we've got 2k, take away k over 8 equals 5 over 2. So this is 15k that's 16k over 8 equals 5 over 2. Divide by 5, clearly you can just use a calculator, times by 8, so we get 3k equals 4, so k equals 4/3. Okay, that's the first part. Heavy over that. Second part, find in terms of G the acceleration immediately after it's released. So this time we've got a tension in the spring. So we're going to use T, take away the weight, which will be mg going down, equals mass times acceleration. T equals lambda x over L. Lambda is kmg, 4/3 mg. X is 2a over the natural length, which is a. Okay, so that gives us, going to cancel the a's, so I've got 8/3 mg. 8 mg over 3, take away mg, equals ma. So 8/3 take away 1. 8/3 take away 1 is 5/3. So 5g over 3 equals a. Okay, and part C. The maximum speed implies a equals 0, which implies it's an equilibrium in terms of forces, which tells us that the tension in the spring equals the weight. So when the two are balanced, it's not accelerating, therefore it must be at its maximum velocity. We know the tension for mgx over 3a. Okay, T is for mgx. Okay, and that equals mg. And get rid of the m and the g, just to leave the 1 here, times by 3a and divide by 4. So x. So we've got the value of x. Now we need to find the velocity. So what we're going to do is find the energy at A, we know. So energy at A we did earlier. If I can find it. 8 mg A over 3. And energy at C, which must be equal to it, is lambda x squared over 2L plus mg x. So 3 over 4, take off from the 2a, gives us 5a over 4. And plus half mv squared. Just to be clear, because the original extension was 2a and the new extension is 3a over 4, 2a take away 3a over 4 will give us the height it's risen. Okay, so it's 2a minus, and that's the extension now, we're trying to find this gap. Now it's just an algebra exercise. So we've got, these two are equal. We've got m's everywhere, we haven't got g's everywhere. M. And it's just a matter of moving these things around. So if we do it, we get v squared equals 16 GA. Depends how you want to manipulate this. Okay, these are all GAs, so you could take that out and you just got a fraction to worry about. So you end up with 16 thirds, take away 5 halves, take away 36/48 lots of GA. To cut a long story short, you get 25 GA over 4. So V equals 25 GA over 4 rooted, which is better written 5 over 2 GA. Oh, sorry, that's not right. 4 times, this is over 12, sorry. 4 times 3, so I'll pick the two square numbers out. 5 over 2 root GA over 3. Hope that made sense.